All right, if we're looking for the greatest common factor, if you've got three numbers, what I suggest is start with the smallest two and work from there. If I start with 24 and 36, and I start looking for numbers that I know go into both of those evenly, start with 2, right? 2 goes into both evenly. I know that because they're even. If 2 works, we've talked about this strategy before, double that, try 4. 4 goes into 24 and 36, right? But you're trying to push this as far as you can. And you look at that 24, if you know 2 goes into 24 in the first place, how many times did it go in? 2 goes in 12 times, right? So now we know 12 goes into 24. Does 12 go into 36? Yes. So far, the greatest common factor between those first two is 12. So what you need to ask yourself is, all right, if 12 goes into 24 and 12 goes into 36, I know it's the greatest common factor for those two. Does it go into 84? Does it? Yeah, it does. It goes in 7 times. So the greatest common factor there is 12. All right, we're just playing with numbers there. We're dividing them in, seeing what the largest value is that goes into all three. Let's start with the smallest 2, figure out the greatest common factor there, then see if it goes into that largest one. All right, another greatest common factor example. This one with variables. 30x to the 7th, 45x cubed, and 75x squared. We got numbers, we got variables put together as an expression. Start with the numbers. Use that strategy like I used on the first one. We've got 30, we've got 45, we've got 75. Take the smallest 2. Between 30 and 45, both ending in 0 and 5 respectively, we know 5 goes in, right? So that's a common factor. The question is that the greatest common factor? Is it? No. What is the greatest common factor? Okay, 5 didn't work, so we try 15. That works. 15 goes into 32 times. 15 goes into 45 3 times. And as it turns out, with 15 being the greatest common factor between 30 and 45, if you check it on 75, right, take 75, divide by 15, you get 5. So 15 is the greatest common factor. Now, there is an x in each of these. That means there is an x in common, so we would include it in our greatest common factor. The rule we've been using, whatever the smallest power is of x, in this case, smallest power be 2, that's going to make up the power on our greatest common factor for that variable. So 15x to the second is the greatest common factor. All right, we're going to factor out the greatest common factor between these two terms. I'm going to set up my parentheses down here. Inside the parentheses, that's where my leftovers go. In front of the parentheses, I take out that greatest common factor. So like we did on the previous problem, looking at the 13 and the 39, start with the numbers. Ask yourself, what's the largest number I can divide into each of those evenly? You know? 13's prime, right? Now, obviously, we can divide 13 by itself. Can you take 39 and divide by 13? Yes. Sure. 13 is the greatest common factor. So we're going to take that out. Now, as long as I'm focusing in on the numbers, let's see what happens here with our leftovers on the inside. Take 13, divide by 13. 1 is going to be left in the first place. Take 39, divide by 13. 3 is going to be left in the second place. All right, now focus your attention on the variables. You've got y's present in both terms. So we know a y is in common. We know we take a y out. Following the rule like we talked about in the last one, you're going to take the smaller power of those y's. So smaller power being 4. Y to the 4th is taken out. Now to figure out the leftovers. You've got y to the 5th here. There's 5 y's. You took 4 out. So there's a y left over, the power on which is going to be 1, because there's only one y left. Second term, you had y to the 4th. We took out y to the 4th, so all 4 y's are gone. Our answer here is 13y to the 4th times the quantity y plus 3. That's factoring out the greatest common factor. So greatest common factor on this one, set up my parentheses, understand that there's 3 terms I'm starting with. There's going to be 3 terms as leftovers inside the parentheses here when you take the greatest common factor out. You go through your 3 terms, focus in on the numbers. You got 4, you got technically negative 12, you've got positive 8. Greatest common factor would be what? Okay, 2 goes in, they are even, but we can do a little better. 4. So we take 4 out. Figure out your leftovers on the values inside. 4 divided by 4, you got 1 here. 12 divided by 4, you got 3 here. 8 divided by 4, we got 2 here. Now when you look at the variables, we've got x's that are present in each of these. We've got y's that are present in each of these. So we know x and y will be out here. The question becomes, what are the powers on the x and the y? So this x, you got a power of 2. This x, you got a power of 1. This x, you got a power of 3. Smallest power on those was 1, right? So x to the first. With the y's, looks like it's going to be the same thing, right? You got a y to the third, a y to the second, you got a y to the first. So an x to the first, a y to the first, that's the best we can do to take out. Looking at leftovers. You've got 2 x's here, took 1 out. 1 x left. 3 y's here, you took 1 out. So 2 y's. Here there was 1 x. You took 1 x out, so there's no x's left. For 2 y's, you took 1 y out, so there's 1 y left. And then you got your 3 x's here, you took 1 out, so there's 2 left. Got your 1 y there, you took 1 y out, so there's no y's left. Your answer is 4xy times the quantity xy to the second minus 3y plus 2x squared. So, there is no greatest common factor on this one. There's 4 terms. If I group the first 2 terms, and I group the last 2 terms, I'm going to take the greatest common factor out of each of those. Taking the greatest common factor out of this first grouping. Regarding the numbers, you've got a 1 and an 8, so greatest common factor is 1. Don't need to take anything out there. The x's are significant, though, because they're in common with both terms. If I take an x out, make that x a power of 2 because that's the smallest power on the 2 x's. Looking at what's left over, which will be 2 terms, right? Got x to the third here. There were 3. You took 2 out. X to the first is left there. There's 1 left over. X to the second. You took 2 out, so no x's are left here, but there is an 8 that we need to include. The trick with factoring by grouping is whatever I get right here that's left over inside the parentheses should match up with my leftovers for this next grouping. So I'm trying to create an x minus 8 here. If you look at what's in common between these 2 terms, you'll notice a 2 is, right? Regarding the numbers, 2 and 16, 2 is the best you can do. This sign will be what I use down here. So plus 2 comes down. Checking yourself, divide 2 into each of these. Goes in 1 time for this one, right? 8 times for the second one. That's how many times 2 goes into 16. So the only thing left to do now, take these little common pieces, move that to the front, create another binomial expression where you put your leftovers. X squared plus 2. There's your answer. We do factoring by grouping again on this one. Group the first two terms, group the last two. Focusing my attention on the first two. You've got a 9x squared, you've got a technically negative 27xy. Regarding the numbers, you can take a 9 out of each of these, right? 9 goes into itself as well as 27. That'd be the greatest common factor there. Regarding the variables, you've got x's that are in common. So I take an x out. More importantly, I take an x to the first out. So you got a power of 1 here, you got a power of 2 there. Smallest power is 1. Left over, you've got two terms. In the first spot here, take 9 divided by 9, you got 1. Had two x's, took 1 out, so there's 1x left. 1x would be left. Second position, take 27 divided by 9, got 3. I took 1x out. There was 1 there, so no x's are left. Didn't take any y's out, so there's a y left. As I mentioned on the previous problem, you got this grouping right here that needs to be consistent with the grouping that's left over for that part. So we're trying to create an x minus 3y when I take my greatest common factor out of the negative 3x plus 9y. As far as signs are concerned, since this is a minus sign, this will be a minus sign. The greatest common factor between these two terms, well, x and y, those are not in common, but you've got a 3 and a 9, so 3 goes into both. And if you check yourself here, negative 3 divided by negative 3, positive 1, with an x remaining. Negative 3 divided into positive 9, got a negative 3 with a y remaining. You take what's left over now in these two groupings, move that to the front. Take your two leftovers, set up a binomial expression to include those. There's your factorization. All right, so when you have three terms, first thing we're doing, we're looking for a greatest common factor. No greatest common factor here. Second thing we move to with three terms is reverse the FOIL process. First positions in these two binomial expressions we're setting up. In the first positions, we're marking x and x here because this x times this x has to give me that x squared. In the last positions, we need things that multiply to give me this, we'll say 40 for now, not worry about the signs yet. If it helps, this is where we list the factor pairs off to the side for 40. You've got 40 and 1, you've got 2 and 20, you've got 4 and 10, you've got 5 and 8. Got to play with it. Got to check by foiling to see if it works. But if you choose 4 and 10, and you check the outside, when you multiply the outside, you get 10x. And you check the inside, when you multiply the inside, you get 4x. You're asking yourself, can I combine these two values to get this 6x back? And of course you can, because you can subtract them. So now you look at the signs. That's a negative 6, meaning this needs to be a negative 10 and this needs to be a positive 4. So on the outside, that gave me the 10x. I'll put the negative there on the 10. The inside, that gave me the 4x. So I'll put the plus sign on that 4. Answer is x plus 4 times x minus 10. It's a good problem to keep you honest. You got your three terms. We're reversing the FOIL process again. Like the last one in the first positions, we're going to mark x and x because x times x is x to the second. Remember, in the last positions, these have to multiply to give you 100. When you list your factor pairs over here, the first thing you should list should be that number and 1. Now notice if you take that number and 1 here, and I know I haven't listed all the pairs for 100 yet, I'm just checking this one out right away. If you multiply the outside, x times 100, you get 100x. And if you multiply the inside, you got 1 times x, just x. If you add these together, that's a way to get 101, right? So if these are both positive, that will create that positive 101, meaning both signs up here need to be positive as well. So x plus 1 times x plus 100 is your answer. So the first rule of factoring is take out the greatest common factor. With 3 terms, it's easy to get in that habit of just reversing the FOIL process, right? And just start there, which is not wrong to do. But you really do need to take out the greatest common factor first, because at some point it has to come out. You'll notice between 3, 24, and 21, 3 goes into all of those. So I take a 3 out. I write my remaining 3 terms. 3 goes into itself 1 time, so x squared is left in the first position. Plus 24 divided by 3, I've got 8. 8x is left in the second position. Plus 21 divided by 3, got 7 left in the last position. You take out the greatest common factor first. And then this part that remains, you ask yourself, can I do any better? Can I break that up any more? That's kind of what you guys are doing on your assignment right now. Take out the greatest common factor, then we do a little more. The only thing we could do to what remains is try to reverse the FOIL process because there's 3 terms. So knowing this x squared gives me the first part, x times x has to go down here in the first positions. What's nice about this one is in the last position, the only things that multiply to give you 7 are 1 and 7. So if you try those, you check the outside, you check the inside. Outside, you've got x times 7, 7x. Inside, you've got 1 times x, which is 1x. If you make both of these plus, that gives you this 8x back. So make these positive. And understand that your answer is 3, got to include that 3, times x plus 1 times x plus 7. All right, so the last of the factoring strategies. Greatest common factor, start with that. There's no greatest common factor here other than 1. Not 4 terms, so it's not factoring by grouping. Not 3 terms, so it's not reversing the FOIL process. 2 terms, though, since it's subtracted, there is a difference here. And as you look at the 2 terms involved, each of these terms we can take the square root of, so this would be a difference of 2 squares. All you do for a factorization of a difference of 2 squares, you set up 2 binomial expressions. In the first positions, we're going to take the square root of this first guy, meaning this is just going to be x times x to give me that x squared. In the second position, we're going to take the square root of 81. Square root of 81 is 9. We'll put 9s in the second positions. And make sure this all works out correctly. If you make 1 plus, 1 minus, you check yourself through foiling and take you right back up here to that difference of 2 squares. So your factorization is x plus 9 times x minus 9.